All right, hello everyone. My name is Juan. I'm from Montevideo. Today I will be talking about collection view layouts. Let's get started. First, what's a collection view? Well, it's an object that manages all the collections of data. And yeah, we can present that with a custom layout. First of all, who uses a collection layout in their apps? Show hands. Okay, most of you. Who uses a custom layout? Something with you? Okay, a lot. All right. So yeah, the collection view is perfect for presenting data in a non-linear way. And it's perfect for bigger screens like the iPad, for example, or the Apple TV. So for example, this is a collection layout that I made, I designed it. Let's get started first with the parts of a collection view. We have elements, items, yeah, which are cells in our collection view. Then we have decorations, like a background in a section, for example. And we also have supplementary views, like headers, footers, a badge we want to show in a particular cell, something like that. So these are items, for example, supplementary views, and then decorations. So let's go first to see what are the classes involved in when using a collection view. We have the collection view itself. We have a data source similar to a table view. This will tell us how many items and sections we have in the collection. We can configure ourselves. It's pretty similar to a table view. Then we have a delegate. This is where we will handle selection of items, for example. And finally, this is something different from the table view. We have a collection view layout object. Okay. We want to make our own custom layout. Well, we have to subclass UI collection view layout. There are at least 6 methods to implement. I put 4 here. We have to tell what's the collection view content size. This will be used for the size of the scroll bar, for example. Then we have to tell what are the layout attributes for the elements in a given rect, in a bound. And this is an array of collection view attributes. These attributes will tell us for an item what's its size, its position, what's the index between other elements, things like that. We can customize that. Then we have to tell for a particular item in an index path what are the attributes for that item. And finally, there's this method, should invalidate layout, and this will be called almost every time. And this, here we have to decide if we want to invalidate the current attributes for all the elements, or we want to keep using what we have. And this is called almost everywhere. It's called even when we scroll in the collection. So it's kind of important to have this in mind. We don't want to process a lot of things on every scroll, for example. So as you can imagine, it's kind of hard to do this. We have to implement at least these methods, but there are much more we can do. We have to take considerations of performance because we don't want to calculate everything all the time. So as you can see there, we need to consider caching. There's a lot of bookkeeping we have to do. It's extremely hard. It's also powerful. Like we can do almost everything with this. But yeah, it's not easy. Perhaps if a designer comes with a custom layout for our app, we say, okay, let's start with something simple first and postpone it and postpone it and postpone it. So let's see how the collection view and the layout interacts all the time. First, the collection view will call invalidate layout to our layout object. Then we'll call prepare, and here we have to, this method by default doesn't do anything, but we can start calculating things like or content size, for example. Then the collection will call this, will ask the layout object for the size, and then it will call for the attributes of all the elements in the visible rect. Internally, the collection view, it might calculate the layout object, the layout attributes for new items, or perhaps pick something from a cached attribute. And then we scroll, and we call should invalidate the layout for changing bounds, and we say yes or no. And if we invalidate, we have to do everything again. So this is really hard, really difficult. And what Apple does is give us the flow layout by default. It's a stock layout. It's available since iOS 6. It's line-based. This means that when it will place an item, and then another next to it, and when the line is full, it will go to a new line. And it supports sections, headers, footers, self-sizing items. It's okay for most cases, but also it can be a bit annoying to adjust some details. For example, that's something new in iOS 13, I think. We have now sticky headers and footers, and before that, we couldn't do anything like that. So this is how it works. It will place an item, then another, and when the line is full, it will go to the next line. All right, let's make a quick demo. Can we switch there? Hold on. Okay, I can see my screen. All right. This is something I was trying some time ago for Toggle, the app I work on. We did a calendar view for our app. It's a time tracker app, so you will have time entries, and time entries are delimited by their start and stop time. So what we did is a calendar view to show those time entries in something similar to the calendar app in iOS. Oops. All right. This is a custom layout we did. We have items, these cells, supplementary views. We have all these hour indicators. This red line is the current time. It's a decoration view. And yeah, it's that's it. What we did. All right, here we are. This is the collection view calendar layout. Well, what we did here is, in this case, it was kind of easy to calculate the content size because we know the day has 24 hours and an hour's height is 80 points or something, just multiplication. But then to calculate the layout attributes for the elements in the rect, we had to get what are the visible items in that rect, and we can translate a rect position to an hour, so we can get the index paths for each element. And yeah, we create the layout attributes for all the elements. So yeah, this is tricky. It's actually super buggy. It's not the final implementation. So let's continue with the presentation. All right. So that's awesome, but it's really difficult to do. But something new in iOS 13, it's the new Compositional Layouts API. Um, it's it's available since iOS 13, and what we can do is define like templates for sections. Um, yeah, it will follow the template. It's super fast and easy to use, and we don't have to worry about caching elements or performance considerations. It's actually amazing. And there are three main building blocks in the compositional layout. We have items, groups, and sections. Let's see what's the API for those elements. But before that, let's talk about sizes. There is this new class, NS collection layout size. It's like a tissue size, but with superpowers. Instead of giving the width and height directly, we use this NS collection layout dimension. And this is what we can use to create like fractions of the parent of an element, for example, or give absolute values or estimated values. So the next item, the next building block is the item. This represents the layout for a single item. Yeah, we give it a size. We can set insets for that element and supplementary items like a badge or something like that. The next building block is a group. And you can notice that the group is also an item. So we can, this is what will allow us to compose items into more complex blocks. There are three main methods to create a group. We can create horizontal groups with items or other groups, vertical or custom. The custom one is interesting because it will give us a closure where we can calculate manually the attributes for each one of the elements. And finally, the sections. Sections represent a section in our layout. We give it a group. We can set also an inset for this section. Give it boundary element supplementary items. These are the headers and footers. Then we can set also decoration items like a background for the section. And well, the final element is creating our layout. We don't have to subclass here. That's amazing. We can use the constructor and give it a section directly. And what this will do is, okay, it will render a section, and if there's another section, it will use the same object for the next one. There is a second option. We can give it that section provider, and what we can create here is different layouts for each section based on the section index. So let's go back to the demo. This is a different app I did. It's an app for numbers. This is the stock flow layout. I gave all the items 50 by 50 size, but let's change this to something more interesting, like a list. Well, this layout, what it has is each item is in a group, and the group repeats itself, and that's it. But we can do more complex things like columns, more columns, or even something more interesting like this. It's awesome to display photos, for example, or if your app has it's a store or something like that. I did 2 versions of this. It's called fancy layout. Basically, this is what the layout does. It will render the main group. It has 2 groups, but also has more groups. But this is the order in which the elements will be rendered. You can see here the code that this big item is the first one, for example. And what I did is that to make this a square, the The width and the height must be the same. Yeah, this source is 50% of the parent. Then we have the small items, which is a quarter of the parent, of the whole collection actually, but not the parent. The parent is only this square, this little square. So it's also 50%. Then we put these small items in a group, in a linear group, horizontal, for example, and these 2 items from a group. And then we make a vertical group with these 2 rows, and everything, all that together compose the main section. It's a lot of code, but it's actually easy to read. There's another one I did using the custom option. I made a little change here, but let's see. Well, what we have here is the custom constructor for the group. It's not a constructor, but it's a factory method. And well, we have an environment. This will give us the traits for the collection view, so we can do something different if we are on iPad or with the split screen. We can adapt to that. Yeah, we have to calculate manually here all the NS collection layout, group, custom item, blah, 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 for each element. We have to get a frame. Yeah, that's basically it. So yeah, it's a lot of math, but nothing super complicated. The problem here is if we want to change something a bit, we have to recalculate almost everything. But with the first option, if we want to add, for example, a content inset in a particular element, we should go and say, okay, big item, dot. Well, to complete this not working. But we can set the inset directly. It looks really nice on iPad also. So if we do split the screen, we can do something different. In this case, I didn't do anything, but all right. There's something else we can do, and I think this is the most powerful thing for the. Go back to the slides. This is the most powerful thing for the compositional layout API. We can do orthogonal scrolling. This change will allow us to scroll in the orthogonal direction of the scroll direction of the layout. So if we have a vertical layout, we can scroll horizontally in a section, for example. And there are different options for that. We can check the documentation. We're out of time, so I won't go on everyone. But this will do grouping and snapping on a particular group and things like that. So it's really powerful. There's a final demo for that. I don't know if you have time. I tried to emulate the App Store layout with that. This is what I did. We have this kind of gallery. Also, this one is kind of different. We have like the top 3 apps, for example, top paid. So this is all done with a collection view layout, with a compositional layout, and it's really simple. I had to do something like this once before this API. I did it without collection views because it was extremely complicated. And yeah, I'm surprised by how easy to do this it is. Yeah, it's really a really powerful API. So let's go back to the slides and finish. One more thing, this is available in iOS 13 only, So you can do something like this if you want to support compositional layouts in iOS 13 only and do a flow layout maybe in previous iOS 13. So let's recap what we saw. Well, we saw what are the elements of a collection view. We saw how to make a custom layout, what are the problems with that, what are the possibilities of a compositional layout, so how flexible the API is. And finally, we saw that also it's easy to maintain and iterate. We can go back to our designers and change something like almost immediately. It's so easy. So if you want to learn more about this, there are some great sessions from WWDC. The first one is from last year, a tour of collection view. It's really good to see how are the internals of the collection view layout. These advances in collection view layout is where they presented the compositional layout API. And finally, something I didn't cover in this talk, but advances in data sources. There are new great APIs to make diffing in our collection views, and the changes animated. It's really powerful. So that's it. Thank you.